Page 76, ordered pairs as solutions. Okay, so every point on the line is a solution to the equation that graphs the line. What do I mean by that? I mean that every point that's on the line, if I have a line here and it goes through the point 2, 3, then if I take my equation and plug in x equals 2, y equals 3, that's going to be true. That's going to give me a true equation. And if I have a point that's 3, 3, whoops, that's not 3, 3. How about 2, 4? I get confused sometimes too. Okay, if I have the point 2, 4 and I plug in x equals 2, I will not get out a true equation. So we can either plug in both of these and see if it's true, or plug in one of these and see if we get the other. Every point on this line is a solution. Every point not on the line is not a solution. Okay, so let's just try this out. Example 1. I'm going to try it both ways. So method A, I'm going to substitute both of them in. I have -3, making sure to get my y first, equals 2 times 2. Minus 7, question mark. I want to know, is that true? -3 equals 4 minus 7, question mark. Yeah, it does. So the point is on the line. Let's try method B, which is very similar. Method B, I'm going to plug in, I'll plug in x and see what I get out for y. Let's try it. So I have y equals 2 times 2 minus 7. I don't need a question mark here because I'm sure of this answer. Y equals whatever this is. I just need to figure out what this is. Y is 4 minus 7, order of operations. Y is -3. So if x is 2, then y is -3. Well, that's what this is, 2, -3. So again, we get that the point is on the line. Let's take a look at number 2. So if we're doing this the same way, we can either do method A, plug in -1 for your x, plug in -6 for your y. Watch your signs and see if this is true. Or you can just plug in -1 for your x and go through and solve for y, and hopefully it's -6. And if it's not, the point is not on the line. So we've got multiple, we could also plug in just the y value and solve for x. That would work as well. So some of these are going to be true, some of these are going to be false. And then the last one asks you to look at a table and say which of these tables could be generated by this equation. Well, if the table is generated by that equation, every point here needs to make this equation true. So take a careful look at this equation, start plugging in either your x value or your y value to find the other, or plug in both and make sure it works. And let's just do one example. I feel like I could use an example here. Let's take a look at C. If I plug in, I'll plug in x. So I'm just going to plug in 5 for x. I have 2y minus 5 times 5 equals 10. 2y minus 25 equals 10. I'm going up, which is kind of bad board work, but just bear with me. 2y equals 35. Y is, well, it's 17.5, but I don't even need to know that. I just can tell that it's not 0, that's for sure. So this is wrong. If we wanted to check another point, we could, but once one point is wrong, we know the whole chart is wrong, unless we made a mistake. I don't think we did though. If we plug in 5 and 0, we're doing kind of the method 1 type thing, or method A. And plugging in 1 here, we get, 5 and 0. Plugging in 5 here, we get 25. Plugging in 0, we get 0. 0 minus 25 equals 10? No, that's not true. So that doesn't work either. Whether we use method A or method B, 5, 0 is does not solve this equation. So which one of these does? Be sure to check them both. If you think the answer is A, you still need to show that B doesn't work. If you think the answer is B, you still need to show that A doesn't work. And that was a quick one.